And yeah, I'll just do a short introduction. So the talk, like on the slide, it was just decision optimization. It was just the actual title was too long to fit it on the slide. So
Great.
the title is translating machine learning predictions into better real world results with decision optimization. And this will be different from the 3 previous talks we had. So the other talks were presentations. So where the speaker first presented something, and then there was a Q&A session. But this one will be a live discussion, and it will also be released as a podcast later. So the previous videos we just upload to YouTube, but this one we will also put to our Data Talks Club podcast without video. So it will be just a conversation.
Great.
Yes. And for those who just joined, so we use a slider for asking questions. So in YouTube, in the stream, if you go to the chat section, there is a pinned message, which you can just click, and then it will bring you to slider. And then if at any time during our chat you have a question, just feel free to ask it in slider, and then we will cover it eventually. And yeah, so I think, are you ready to start?
Yes.
Yeah, so let's start. So today we'll talk about decision optimization, which is about making better decisions with machine learning. And we have a special guest today, Dan Becker. And Dan is the founder of Decision AI, which is a company that specializes in making better decisions with machine learning. Welcome, Dan.
Glad to be here.
Yes, thanks for coming. Before we go into our main topic of decision optimization, let's start with your background. Can you tell us a bit about your career journey so far?
Yeah, I got started with machine learning in 2000. I was part of a startup that was using it to help companies optimize how they posted things on eBay, which was very popular at the time. And we worked on machine learning for about 6 months, and it was a total and complete failure. The predictions were not good. No one understood what we were doing. We didn't understand what we were doing. And after 6 months, we switched to just using simple descriptive statistics. And I came to the point of view after probably 9 months at the company that machine learning would never catch on. It's a name that sounds cool, but I said it's just never going to work. And there's sort of a dead end. And I got a PhD in econometrics. And then in 2009, I started competing in Kaggle competitions, but I was just using very simple statistical techniques because I thought that was what was best. And when I did that, I found I was in almost last place. And I came to realize that machine learning had improved so much that actually it wasn't a dead end. It was just that we were bad at it 20 years ago. Got second place in a Kaggle competition with a $3 million grand prize, but no prize for second place. And then had the good fortune that led me to do consulting. I've done consulting with a lot of big companies. Was an early employee at Data Robot. Worked at Google as a data scientist for a few years, and then in January of 2020, I started Decision AI.
Oh, that's you mentioned you tried Kaggle in 2009, right? So it was like probably the first competition, right? Or
it was one of them. So they're at maybe 3 million users, and my user ID is 9,000 or 9,028. Okay. So I was definitely a very early adopter, and yeah. I did well in competitions in the early days. And now when I see the complexity and the intelligence of what people do, I realize that it's much more competitive than it used to be. But yeah, I was a very early adopter. That was their first big competition, at least.
Mm-hmm. Yeah, I started on Kaggle like in 2015. So like I guess Kaggle was 6 years old already. But when I look at what competitions we have now, they are so different from what was there 5 years ago when I got there. So indeed, the level of complexity is rising. It's interesting. Yeah. So what is decision optimization? What kind of problem it solves?
Yeah. So it really is a lot like what it sounds like. The easiest way to make that clear might be an example. So I really started thinking about making a company around this in part because of a conversation that I had probably 4 or 5 years ago with a friend of mine. He works for a very large US-based airline. The number one and most important problem that they were working on is how do we set prices for each of our flights? They build a machine learning model, and these guys, they had great data scientists. They build these machine learning models, and because they update their prices daily, the model that they build predicts for any given price how many tickets could we sell on each of our future flights. So we got flight 1000, it leaves March 20th. If we charge $400, how many tickets will we sell before the next time we reset the price? Or if we charge $500, how many tickets will we sell before the next time we reset the price? Now, decision optimization is going from, all right, I've got a machine learning model that makes a prediction, in this case, how many tickets could I sell, to I've got something I control, in this case, that's the price. I've got something I care about, in this case, that is total revenue for the flight before it takes off. And how do I actually, like, what price do I set? And the thing that they saw, which is I see all the time in data science now, is if you had one day until a flight takes off, you can now build a machine learning model and it tells you you could sell 6 tickets for $400 each or 5 tickets for $500 each. And now I could just say, well, price times quantity. I could just look at my revenue and say which of these is better. But most real world situations have these dynamics that play out over time. If I said you could sell 6 tickets for one price or 5 tickets for another price, but you've got 90 days before the flight takes off, which of those is better? Knowing that the tickets you don't sell today can be sold tomorrow, knowing that if you lower your price a lot to sell more tickets, then tomorrow your competitor is going to lower their price, and so it's going to mean that you make less money in the future. Which of these is better overall as we think about the real world? That is, decision optimization is just how do we make good decisions, but it really is a very challenging and technical field when you apply it to real world situations.
Mm-hmm. So basically what you're saying, correct me if I'm wrong, is we have a model. And in this particular case, it was a demand forecasting model in a way, like you predicted like how many seats on a plane you would sell for like for that amount of money. So basically like profit per day, I guess. And the problem is we have this model, but how do we use it in the most effective way? So we don't hurt ourselves by by selling cheap tickets today and running out of cheap tickets, and then tomorrow a competitors comes.
Exactly.
Okay.
Yeah.
Okay. And but this is like, does it also work for? So as a data scientist, like at an internet company, I mostly deal with binary classification problems. So like, and I guess this is true for industry in general. So this is what, like, I think if you go on Kaggle and check, I think most of the competitions will be classification competitions, and binary classification is like most of them, most popular one. What kind of problems we can have with with optimizing our decisions there?
Yeah. So let me give you 2 examples. So let's do binary classification problem. Maybe it is financial fraud. And actually, I'm working with a company where the service they sell is an API. You send them information about a transaction. They send a response that says it's 5% likely to be fraud. Okay. So now you have the question, what do I do with a transaction? It's 5% likely to be fraud. Should I reject it? Should I process it? In many cases, there's some third option to investigate further. And so in the narrowest sense, the decision optimization part of that is to say, what is my threshold? Let's simplify it and say, all I do is either accept or reject. The simplest thing that you could do is say, I need to figure out what that threshold is for where I reject it. And there's a technique, I call it profit curves. I've talked about it a lot, or sometimes also called revenue curves, where you can basically simulate if I have a 3% threshold for anything above 3% likely to be fraud, I reject it. Anything below, I don't. If I have a 4%, if I have a 5%, what's the business impact of that? And so the simplest thing that you could do is say, well, I want to optimize that threshold, and the payoff to doing that. That's a pretty simple thing to do, and the payoff to doing it is very large. I think even that is really a simplification of what is needed in practice. So I was talking to an insurance company. They have claims that come in that they think are likely to be fraud, and they send it to an investigator to say, is this fraud or not fraud? And then um, if it is fraud, then they don't have to pay it. So they were using a very simple threshold like the one we talked about. If it is 10% likely to be fraud, then we investigate it. If it's less than 10% likely to be fraud, we don't. That, to many people who have worked in classification for a long time, that idea of I run it through a classification model, get a probability, and then either accept or reject it, like that seems natural.
Mm-hmm.
And that is if you think about it, is the craziest thing to do. So if they have a claim, it comes in, it is for 50,000 euros, and it is 9% likely to be fraud, they'll say, well, it's under 10%, we don't investigate it.
Mm-hmm.
Now they've got something that comes in, it's for 500 euros, and it's 10% likely to be fraud.
Mm-hmm.
So the expected value of investigating the 9% of like that, the expected value of savings is it's about 90 times as large, and yet they don't do it because we've been so pulled in by where we did a classification model, the output of it is a probability, and we think of that so narrowly that I just see people do these crazy things because we look at that probability in isolation.
But shouldn't model be able to pick up on that, like to see, okay, the sum is large, then yeah, probably more likely or less likely to be fraud, or
Yeah,
not always.
so the 10% and 9%, those could have considered the likelihood of being fraud, and yet it could be the case that maybe small things are more likely to be fraud hypothetically. So the model figures that out, but then it says I still have a 10% likelihood of being fraud, and the value of investigating that,
I see.
it accounts for it as it affects the probability, but the value of actually running the investigation is 10% of 500 euros. So that's, I get 50 euros in expected value by investigating it. And so you see where I'm going,
Mhm.
of 9% of 50,000. And so yes, the probability may reflect the amount, but we need to do more than that.
Mhm. Yeah, so we have a similar, like at the company where I work. So we have a moderation team, and so the company is like it's online classifieds. So like think like Craigslist or basically the place where you go sell stuff you don't need. So the moment somebody publishes something, somebody creates a listing, we want to understand if this listing is fraudulent or not. And then if we think that it's fraudulent, then basically a moderator, or like if it could be an automated decision, or a moderator uh, looks at this. And the way we typically do it, and the way it's done in industry usually, is we play with precision recall, and we play with the threshold. We see, okay, this level of precision is acceptable for us, this level of recall is acceptable for us, so we're setting thresholds to this to this amount, like to this value, and then we just roll it out. And then yeah, so this is how a system works. But yeah, as I just understood from you, this is not an ideal way of doing this. So how should we approach it differently? How decision optimization can help us?
Yeah, so decision optimization really requires is very use case specific. So we'd have to talk about it. I guess the first question that I would ask is every type of fraud, not every type, is every fraud equally painful to you as a platform?
Yeah, probably not. Yeah, I guess
Probably
not.
not.
So we need to
So
put like a number to each type of fraud, right?
yeah, so you'd want to think about for each post, maybe I'd say I'd like to get a number and say, if it is fraud, what is the type of fraud? And maybe there are even two people, to go back to something that's similar to that thing that I saw in insurance. Maybe you've got two different posts about someone selling a bicycle,
Mhm.
and one of them is a 10,000 euro very expensive road bike, and the other is just a cruiser bike that gets someone, one is a racing bike and one is getting someone around town. And if they're both the same probability of being fraud, maybe we'd have to think about the trade-off, but maybe you should be more concerned about someone getting defrauded over a
Mhm.
10,000 euro racing bike than over a cruiser bike. If there's if it's in a personal section and you think someone is going to get assaulted, you should have different standards to protect someone's physical safety than you do,
Mhm.
um, if something is multi-level marketing and you think maybe they're going to buy a bunch of plastic bins
Mhm.
and not realize the plastic bins aren't high quality or something.
Yeah. So, so yeah, I guess so. Yeah, if we do that, so right now for each case, we attach some number to it. So we know that, okay, cars are more expensive. We should pay more attention to cars, let's say, than to cheap bikes. So we did that. And what do we do next? So we have that. We have like these prices or some perceived value or perceived price of an item. Then we have the predictions of our classifier. So we have these two things. So what
Yep.
do we do next?
Yeah. So the end product, what you'd like to come up with is a single function that takes, it can be think of it like a Python function. It takes in a bunch of information like the probability of it being fraud, the type of fraud, the cost of the item, I'd need to understand your business better, but maybe you have some people who post repeatedly,
Mhm.
and it would be very painful to you if you mistakenly tag them as fraudulent, and
Mhm.
so maybe you have different customers
Mhm.
who you value in different ways, but you'd like to come up with one function that considers all these factors, and the output of it is accept or reject, or perhaps you have some third category, which is
Mhm.
manually investigate. And now I would go to, and it could be something the data scientist does in many companies. Um, I think the process, because of this, who works there, is a little bit different at tech companies versus, I talked about insurance companies. I've talked to banks, and so you probably have a different process in terms of who the people are who make this decision. But it really is for you to simulate for any given decision rule what happens, who are the customers we upset, what are the types of fraud that happen, um, and then for us to visually be able to say, well, we've proposed a few different decision rules. Which of these is the outcome that we're most happy with? And in many cases, that outcome will be, we might even look at if you charge people for posting, what's the lifetime value of the people
Mhm.
who we upset, or what fraction of them leave the platform? And the thing that I think data scientists probably have made the biggest mistake in is thinking about each of their machine learning models atomically, or alone. And so it could be that the right thing to do, and again, not knowing your business, it could be the right thing to do is to say, what's the likelihood of this being fraud? And that's a machine learning model. And then I've got another model that says, conditional on tagging this as fraudulent, if that's a mistake, what's the likelihood that this person gets upset and never posts with us
Mhm.
again? So now I've got two models that I'm connected, and maybe you've got another one that says, what is the lifetime value of different
Mhm.
customers? And now I've got three different models, and I'm incorporating all of those in a way that, because if I were to ask someone to explain how the business works, they would describe it as this like really complex flow chart. And for us to model that in reality requires that each of these pieces talks to each other.
Mhm.
But at the end of the day, you want a decision function like a Python function, and you want to simulate what are the outcomes of
Mhm.
each of these and which am I most comfortable with.
Yeah, so we get a bunch of models, fraud detection model, LTV prediction model, some other models. We just put them together into a single Python function. We somehow encode this logic of, making this decision, and then I guess we just use this function to make decision. Or do we experiment with real customers, or maybe there is like a safe environment where we can play?
Yeah, and this is another place where there are a few different tactics. Um, if you are in a business where you have a nice way of doing some sort of A/B testing,
Mhm.
um, A/B tests and experiments are incredibly reliable. So, like, we should do them
Okay.
where that's possible. Um, the core of Decision AI, the company that I've built and the software that we've built, is to build is to make it easy to build and visualize a simulator or an environment that takes in these different machine learning models. And now in this simulator or in this almost sandbox, I can try out a bunch of different decision functions. And the decision function is the thing that we'll eventually deploy. That's this Python function. But I'd like to be able to see what happens if I run this decision function. And that's the thing that we specialize in. And then the decision function, like you said, is the thing that I eventually deploy.
Mm-hmm. So ideally, A/B test. If there is no way to do this, then we can try simulation and then play with the parameters of the decision function there.
That's right.
But who should create? Like you mentioned, that it should be a data scientist to create who creates this decision function. But I'm wondering, like, isn't the purpose of machine learning is to avoid, putting the rules in the decision factor, like in this decision function? Like maybe we can use machine learning to define this decision function for us. That's the promise of machine learning, right?
Yeah, I mean, I would make a distinction between, so if you were to build a machine learning model, what is the API for a machine learning model? Machine learning, whether you build it in XGBoost or TensorFlow or scikit-learn or wherever, the one thing that is consistent is that it's always .predict. So if I were to put that in plain English, that is to say what will happen. And so if you were to compare machine learning to the way that we built models 10 years ago, we were using linear regression or some sort of like GLM model. And we had to do all this feature engineering very manually in order to make better predictions. Machine learning makes that prediction, what will happen, more automated. Now we get to the step of what should I do about it? And what should I do about it is a very different question than what will happen. There is a branch of machine learning. It happens to be reinforcement learning, which is to say I've got some goal or some objective, and I want to optimize that objective in a very complex environment. And so there is the promise that someday machine learning, in this case reinforcement learning, will do this job for us. We're not quite there yet. And so the reason that we're not there yet, if you follow the reinforcement learning research literature, what are the big breakthroughs in reinforcement learning? So there was AlphaGo, very good at the board game Go. There was OpenAI had something that was very good at the video game Dota. And the thing that is consistent is that the breakthroughs, 10% of them are in robotics, but 90% of them are in games. And the reason for that is that with games, you can just play it in a simulator, which in this case is you just play the game yourself. And so AlphaGo, it's terrible, worse than a beginner for a billion games, but it can play a billion games in a day, and it can play a billion games the next day and the next day and the next day. And so the thing you need is a simulator where you can try out different rules in a simulator and in this dynamic environment and see how things progress over time. I don't think they're, yeah, we need that type of simulator for environments that are very dynamic. And we are exploring how do you take decision AI and use reinforcement learning, but you cannot take a conventional supervised machine learning model and have it do this type of optimization of what should we do to achieve some broader goal. And that's because of the narrowness of supervised machine learning models.
Yeah, makes sense. So basically, like in ideal world, and we are still not there, we would take all our supervised models, put them into this sort of ensemble model decision function, and then train this model with reinforcement learning. But we are not there yet. We don't have like proper environment where we can experiment. Well, not always where it's easy to train this model. So we usually do this manually, right, and code these rules in our decision function, right?
Yeah. And then I guess the other thing I'd say is you've got some basically, I'm going to call them rules, which are very straightforward in our heads, and yet it would be hard to learn from machine learning. And so the best models of if we go back to the airline example, the best model for how does that whole environment work is one that combines things we know and things that some structure that we know and things we can learn from machine learning. So for instance, we know that the total revenue on a flight is the sum of the revenue today plus the revenue tomorrow plus the revenue the next day until the flight takes off. So that's something that is much simpler for us to encode. It's just an identity. There's no error when we write that down. And the idea that a machine learning model would have to learn that, like, we just don't really have the right data to learn that. And it'd be, if you said I want a machine learning model to learn that, it's just very awkward. And the ML ops around it are much more complex than just saying I'm going to encode a few of these handwritten rules. And there are some places where we don't have data, but we've got some knowledge. And the right thing to do is to combine some of these rules with machine learning models, because in some cases, the best knowledge is knowledge in someone's head, unfortunately. And we'd like to get to a place where you just hit a button and everything works, but we're still not there.
Yeah, and I guess that person is usually not the data scientist. It's some kind of some sort of domain expert, right?
It really varies a lot from business to business, and I see, because of what we do, I see so many different frameworks, human frameworks around how these decisions get made. A lot of tech companies, it is a data scientist, and maybe the data scientist talks to a product manager and they sit down together to do it. It really varies a ton based on based on the business and how their divisions are set up. For this to be done well, because data scientists and analysts think in terms of equations, I think that it really benefits by having a data scientist as the fingers on the keyboard. But it is something where maybe you get the data scientist and the VP who just knows the business well, or the stakeholder. Maybe they sit together and work on it. But yeah, it varies a lot from business to business.
Makes sense. Yeah, I'm curious to know what are the tools that are available for this. So I guess that the company where you work develops a tool for that, for decision optimization, right? So
That's right.
how does the process? So let's say I have these three models: lifetime model, customer lifetime model, then I have this fraud detection model, then I have some other model. So how do I use this tool to actually make our decisions better?
Okay. Yeah. So let's start and say, so the primitives are your machine learning models. From those, we're going to have a simulator, which is the simulator is going to incorporate these and say, if you use a given decision function, then here's what will happen at the business level over a long period of time. So we've got the models, the simulator, and then the last part is the decision function. And so the first thing that you do with our software is you take your machine learning models and we have a web-based app. You just drag and drop those web-based those machine learning models into our web-based app. So you could pickle a scikit-learn model, or you can pickle an XGBoost model, and you just drag and drop those in. And now we have a domain-specific language where you can write out some formulas that are the types of formulas that I mentioned in the airline example. The number of tickets we sell today is whatever we had yesterday. Sorry, the number of tickets we have to sell today is whatever we had yesterday minus what we sold yesterday. So a very simple formula. What do you sell on any given day? Well, here we're going to go and consult the demand model, and you use it in this. I've got a very Pythonic way, demand model.predict, and you feed in the arguments. And so we are going to write out a few different formulas for how the different variables evolve, and some of those will be a function of the machine learning models. And now the simulator runs this and says, all right, for a given, let's say, pricing function, here's our price on day one, here's how many tickets we sell. Given what happened on day one, it will now simulate into day two and say, well, what will the competitor's price be on day two? That could be a prediction from a machine learning model that takes in the price we set on day one. What will we sell on day two? So after it calculates everything on day two, it will now move forward to day three, For the competitor's price on day three, it'll look at what happened in day 2. For how many tickets we sell on day 3, it'll look at the competitor's price on day 3. So it's really propagating information from one machine learning model to the next and doing that as a sequence over time. And the exact way that it does that is going to depend on some structure or some formulas that you wrote.
Yeah, I'm curious, like this must be quite a complex environment. So I imagine that it would, like if I wanted to implement something like that in an environment like that with, just using pure Python and encode all that, that would probably take a while, right? But
yeah, so when I was at Google, we worked on some projects that had this type of simulation technique. And the thing that I found is if you're doing this in raw Python, you're never gonna make a simulator that is totally perfect, but you could do something that is reasonable in much less time than it takes to build a machine learning model from scratch. Because once you've got the machine learning models, a lot of it is some domain knowledge. And so in Python, in raw Python, you can do this. It's a little painful to set up, but the thing that was most painful is to iterate on it. So you create this simulator. You're going to graph some results. You take it to someone who knows the business well, but who's not a data scientist, and they say, you didn't account for such and such factor. And now in this complex system where everything integrates together, to iterate is really very, very complex and messy. And you need to calculate things in just the right order because you're piping information from one, in a sort of DAG style or Airflow style way, from one calculation to the next. And so to do it in raw Python is possible, but especially when you want to iterate and maintain it is very, very messy. And that's one of the problems that I think that's probably the number one problem that we solve. With our domain-specific language.
I'm just curious, how companies use that now, if not like, are there many maybe open source tools or people just do scripts in Python and use raw Python to create this environment? How do companies do that these days?
Yeah, I mean, there aren't great tools for it, which was why I started Decision AI. The way that we did it at Google, the few companies that I've seen who are doing something like this are either doing it using raw Python, so just NumPy for the calculations, and then they're obviously bringing in their TensorFlow or PyTorch or whatever models. But the way that they connect them is very low level raw Python, and then I've also seen sort of proof of concepts that are using probabilistic programming languages. So that would be something like PyMC3 or Pyro. I have a hunch that someone sophisticated somewhere out there is doing this with that type of, with something like PyMC3. But I haven't seen it applied in more than a proof of concept or like a blog post about it type of setting.
Okay, so basically the only alternative now is to encode it manually, or maybe like somewhere at Google or larger companies, perhaps they have something with this PyMC, but this is not something available for people to use.
That's right. If someone is doing this and they don't want to use our software, which is, by the way, available for free, so I think they should use our software. But and I like I said, you can iterate 10 or 20 or 30 times faster with our domain-specific language for this. But yeah, the alternative is to do it in raw Python, and it's certainly possible.
Okay. Yeah, so like coming back to my first question today about your career journey. So you mentioned a few things. So you competed on Kaggle, then you work on in DataRobot, then you worked at Google, and then you left Google and started Decision AI. So I'm curious, what did you see there in the industry that led you to this decision to that's funny, to start a company called Decision AI?
Yeah.
So why did you decide that? So what did you see in the industry?
I saw that 80% of the time when I talk to a data scientist who is using machine learning, they are, I'd say for 80% of applications, there is an important decision step that comes after the machine learning model. No one, and most people don't realize it. And in many cases, they're deploying models, and then the rest of business actually doesn't care about the results, or I talked about my friend who works at an airline. Actually, his group got cut in half as airlines have these financial struggles. But why did that happen? It's because they were not able to turn accurate predictions into good decisions or better business results. And I think 20% of the time, that last mile from prediction to decision is so easy that you don't need to think about it. It's almost obvious. But I would say 80% of the time, there's so much to be gained. And I actually have I strongly believe that machine learning is better than the way that we did models, with, let's say, linear regression. And so the way that we've improved predictions has made the world more efficient. I think that being rigorous about how you make these, about how you use your models, has an equally large payoff. And 5 years ago, when I was telling my friends, hey, you should do this sort of simulation thing that we were doing at Google, they all said I wouldn't know how to do it. Or in one case, I worked with someone outside of Google and said, hey, let's do this together. And it was just so manual and so painful that, that we couldn't do it without custom tooling, and that tooling doesn't exist. And so, yeah, I think the need for that tooling and for people to think about decisions more rigorously is so important that I couldn't think about anything else. And I would see all this machine learning research, and you'd see this improved the state of the art. Before, the best AUC possible was 0.9, and now it's 0.91. Or, we had an accuracy of 85%, and now we can make it 85.5%. And someone worked so hard on this. And then in all the places I saw it used, you build this really accurate model, you work hard to make it accurate, and then the way you use it is so bad that you almost just throw it all away. And I can't even see most machine learning now without going, how is it that you spent so much time on one little piece and then you throw away most of the utility by not using it efficiently?
Mm-hmm. Yeah, that's it does resonate with what I see. Yeah, that's a good thing to do. And since this is such a good thing, so how can I, as a data scientist, start integrating it in our workflow? In actually, so let's say we have this problem that we want to solve. We think that decision optimization is the right tool. We played with this, and they think that what we see in simulation indeed looks useful, looks promising. So what are the next steps? How do we take this decision function that we did in simulation and apply to our problem?
Okay, so I think the first thing that I should emphasize is that, like so many things in life, there's a big payoff to doing a little bit better than you do today. And so the thing that I suggest to everyone, if let's say you're doing binary classification, the thing that I suggest to everyone, and you can almost do this on like a piece of paper, but it's so easy, is to start with, you've got a classification problem. Just talk to someone in the business and say, what is the actual monetary value to us of every false positive, and what's the monetary value of every true positive? And now we can just do a transformation on the confusion matrix and say, how many false positives and true positives and false negatives and true negatives do we get if we set our decision threshold at 10%? What if it's 11, 12, 13? And for each of these, you can calculate out what's the monetary value of using this threshold. So this, you don't need our software for this. This is really like the very first step. But even to think about rigorously, though not in a very mathematically simple way, but at least rigorously optimize that decision threshold the same way that you were analytical in everything that you did up until now, so that you're achieving some broader outcome, is I think the very first step. Beyond that, and especially if you are in a situation where you think there are dynamics over time. So some customers, if we upset them today, that is going to that's going to affect our business tomorrow in a way where it's different from one customer to the next. Now a simple decision threshold isn't the optimum. So being rigorous about getting to some decision threshold is better than not being rigorous at all. But now letting it vary is the next step. I think that I would really recommend to anyone that that they check out our software. Like I said, you can use it for free, and even having the mental mindset shift of saying, I'm going to optimize how we use our model to make decisions, even if you don't do it perfectly, just having that mindset shift and saying, all right, I can see the dynamic impact. Here's something that's going to show up on our company's, let's say, profit and loss, or here it's going to show up on the number of customers that we have a year from now. Trying to model things that your CEO cares about, even if you don't do it perfectly, is a big step forward. And like I said, I would really recommend to everyone that Decision AI is, our website is www.decision.ai. Our app is app.decision.ai. And I would really recommend to everyone to explore it, and really start at least approximating what is the ideal way to make decisions based on our models.
Yeah, I actually meant a slightly different thing. So let's say we already played with decision AI. We found this perfect, not perfect, but good enough, reasonably good decision function. So do we export it and use it in our production, or how does it look like?
That's right. You're gonna deploy a RESTful endpoint that is, it takes in whatever the input to that function is for your decision function, and it's gonna return, we accept this transaction, or we reject it, or whatever the decision is that you need to inform. You're going to deploy a RESTful endpoint, which is that decision function.
Okay, so like to the rest of the organization, it will look like a usual web service REST endpoint, REST API that they send features and get back the decision. So nothing will change from the integration point of view.
That's right.
Okay, that's cool. And who should drive this? Like, the initiative of trying this thing, should it come from a data scientist? Should it come from a product manager? Like, and if it's a data scientist, how can they explain the value of doing this thing, investing in that thing?
Yeah. So I personally think it should be the data scientist. The data scientist is spending so much time building machine learning models, and if those models don't pay off, then both the data scientist, and if they're accurate but they don't pay off in a way that the rest of the business can see, both the data scientist and the product manager are in big trouble. But especially the data scientist, I'm seeing more and more companies where there is pressure on the data scientist to prove that their models are leading to not better root mean squared error, but are leading to better profitability. And so I think the data scientist really needs to take the initiative. And this is a very analytical process. And so I think the data scientist really needs to be bought in. They will need to bring in the product manager. But I think in many cases, they'll find that it's actually a quite easy sale where they say to the product manager, what is it? Why don't we start with what is it that you care about? Not related to data science. What is it that you care about? And it could be the product manager has a metric that they really care about, which is I want to maximize daily active users. Okay, daily active users, it's going to trend in different ways over time. But if that's the number one thing that they care about, then now the data scientist and the product manager need to sit next to each other and say, all right, how do we go from, we've got a prediction for whether a given, what we're going to recommend to a user, or whether a given posting is fraud. How do we go from that, sketch it on a whiteboard, to daily active users? So a certain type of fraud, if it happens, it's going to hurt our reputation. and here's the impact of our reputation on daily active users, or there's some way of tracing from the thing we control to the thing that the rest of the business cares about. But once you say, hey, the thing that you most care about, we're gonna start optimizing for that, it's a pretty easy sale.
Okay, so basically speak in terms of metrics that business cares about, not in terms of accuracy and whatnot.
Yeah, I mean, accuracy is only a tool to optimize things the rest of the business cares about. And so you really want to start with, what is it that other people care about or will be excited about? And then you're going to ensure that you achieve those broader goals.
Yeah, thank you. So just want to remind that if you want to ask Dan any questions, so you can use the slider link that is pinned in the chat. And I have one more question, or maybe a couple more. So in your opinion, in which cases we don't need decision optimization? Maybe like, maybe there are some simple cases and just our model is good enough, like just
Yeah,
logistic regression.
There are certainly cases where, and I don't always say the model or the prediction is good enough, but there's certainly cases where the prediction is good enough. It's interesting. There's some an example that might come to mind is Netflix. So Netflix, they want to recommend things that if you watch it, you'll rate it highly. Even there, so I know when I was at Google, I talked to folks at YouTube. So you could say, maybe we want to optimize for what someone is going to thumbs up. The thing that YouTube did is, for better or for worse, is they said, we really care about someone continuing to watch YouTube for a long period of time. So the thing they predicted is, if conditional on us showing this video next, how much time will someone spend on YouTube over the next 6 months? That's if you had that prediction, in many cases, that's close enough to the big picture metric that's the prediction is probably enough. So there are certainly cases where the prediction is enough. It's funny, normally people ask this and I normally come up with examples, and I'm sort of blanking now on what the canned examples are that I usually give. I mean, even recommendation engines, if you're recommending a product, you might care what the markup is on that product. So it's not that, and for some reason I'm blanking on the examples I usually give, but there certainly are cases where you say, if I had this prediction, there's nothing else that matters, and that's enough.
But that sounds like a very complex problem to predict how much time a person will spend in the 6 months on the platform. Like, this is probably an enormous model.
It's super complex, and the things that can happen if you have YouTube scale data are different than the things that can happen almost everywhere else. And so yeah, you're absolutely right that that's a very complex problem. And yes, so there are things that happen at big tech that and especially at YouTube, that don't happen
and I
else.
imagine that probably in this particular example, this decision function is already encoded in the model. So like, because of the complexity, you kind of sort of have it in the model already.
Yes, and that's right. And in their case, just by the so there's a lot of stuff happening in their models, which I only know somewhat as an outsider. I don't know all the details of. I wasn't super close to anything that the YouTube team did, but yeah.
Okay. What trends do you see in data science as a whole?
Yeah, I mean, I'm working with a lot of companies on supply chain problems, and especially, and more broadly, almost everything that I do at Decision AI is tabular data. And one of the trends that I've seen, which I think people should be very, very worried about right now, is it's frequently called train test drift or concept drift. Of, we're going to build a model. It's using historical data because all data is historical. And now we're going to predict, if we run a retailer and we say, I want to predict how how many cans of something, cans of tomato sauce I'm going to sell. And I'm going to deploy this model. I'd use it to predict what's going to happen next week. Well, the data that I collected, the most recent data is from 2020. The way that people bought groceries in 2020 was so unique that finding whatever patterns your machine learning model is going to find with data from 2020 is not going to happen in 2021. And so then they said, well, maybe we should go leave out 2020, build on data that's from, let's say, 2017 to 2019. And they say that's actually not, or that's not so representative of what the world looks like in 2021. And so these concerns about train test drift and concept drift are really front of mind for most people who are deploying machine learning models today, in a way that I think it wasn't front and center. Certainly not. So yeah, before 2020, it wasn't front and center. And in 2020, a lot of companies said, all right, we're just going to not rely on predictions for our supply chain decisions. We're just going to guess.
That's an interesting trend, right? So not relying on data science anymore.
And now they're coming back and saying, all right, in 2020 we guessed. Now we think things are not so crazy. We want to move back to using machine learning for forecasting, but we want to be really smart about how we account for concept drift or train test drift. That is the fact that the world that we live in over the next 2 months looks unlike what's happened in the past. And we need to figure out a way to use machine learning, but then make those sort of adjustments.
So sort of we need to make do with whatever data we have available for the last, I don't know, 1-2 months, right? And we cannot go back to 2020. We cannot back to even earlier years because this data is not representative. So the best we can do is guess or use very recent data, which is not enough, right?
But and then the other technique, which is quite common with this concept drift, is I guess there are two broad approaches. So one is frequently called model monitoring, which is just we want to make sure that every day we have a dashboard we can go to and look at. Ideally, was our model less accurate yesterday than it was, when we validated it? In many cases, you don't get the ground truth in time to see the model's accuracy over a one-day period. But in those cases, people look at something called covariate shift, which is to say, if I look at the data that I've used to make predictions after I deploy the model, if I look at the data from the last week, or let's say the means of that, are those similar to the means from the training data? And if they are, maybe it's okay to leave this thing in production. And if not, I need to be able to refresh the model very, very quickly. And so that sort of model monitoring is front of mind for people today in a way that it hasn't historically been. And then there's some approaches that I'm talking to people about quite a bit, which is to say, I have a hypothesis about how the next month will differ from the past month. I want to use a machine learning model, make a prediction, but then I want to programmatically make some adjustment based on my hypothesis about how the world will change. There's some machine learning explainability. It starts to get really technical, but there's some machine learning explainability techniques, especially with something called SHAP values, where you can make these types of adjustments programmatically after you get the output of your machine learning model. So I'm talking to people about that. But it's front of mind for everyone now of we just live in a world that's changing so quickly that we're concerned about how much we rely on models of historical data.
That's indeed a complex problem for data scientists to solve, and not just for data scientists, for businesses. Yeah, I think that's all for today. So maybe last question: how people can find you?
Yeah, so on Twitter, I'm Dan S. Becker. You can, I'm on LinkedIn. I don't know. You can look me up on LinkedIn. I'm a founder of Decision AI. But people also should feel free to, if you have a data science question you're struggling with, I love chatting with people about how they go from, I know machine learning, which is something that so many people know now too. All right, we want to use this as effectively as possible. If you've got a challenge, drop me an email, dan@decision.ai. Always enjoy chatting with people about it, and we'll love to help. So that, and then Dan Becker on Twitter.
Yeah, thanks. Thanks for, I shouldn't say thanks for coming. Thanks for joining. So these times it's Zoom calls, but
Yep.
it's better than nothing, right?
Yeah.
Okay,
No, it was
thanks a lot for joining.
my pleasure.
Yeah. Well, and thanks everyone for attending. It's been 4 hours, so not everyone stayed till this last talk. So for those who stayed, thanks a lot. For those who didn't, this will be of course uploaded as a separate video. And yeah, thanks then for coming, and thanks everyone for attending. And see you next week. Goodbye.